Hello, and welcome to another FHIR for Developers tutorial video. My name is Gino Canessa. Today we're going to start on a new series of content. This one is all about our most requested topic, which is profiling. So today's video is going to be a little more informational, a little more level setting. We'll start getting into code in the next video in the series. So if you're not interested in getting into the nitty-gritty of these, then I'd say you'll want to pick up on the next one. So before we get into it, what do we mean when we talk about profiling? Profiling in FHIR is really a combination of two things. It's constraining and extending, which is odd to say that it's both of those things at once. It helps to keep in mind that FHIR is one of FHIR's main goals is portability. So they want FHIR to be able to be used absolutely everywhere. But at the same time, we are restricted in what we can define in FHIR because we need to build things out, test things, get approval from different people, all these things. So if you have a very specific use case, there's very little chance of the fields you need being added to the specification because it's not generic enough that it's worth, adding your specific thing into patient, which needs to be used by everyone, when you can use an extension. So that's really what profiling is for. Profiling is for saying, I want to add these extensions to what my core definition is. So I want to make sure that these things are going to be available and present. And conversely, I want to constrain the standard. I want to be able to say, yes, almost everything in patient is optional, but in my use cases, these fields are required and expected to be present. So kind of with that general overview, let's jump into some of the documentation. We can see here we're on the profiling page for the current release, FHIR 4. And again, I don't know if I've touched on this too much. Usually when we're in FHIR, we're just going through resource pages. But in this case, there are some of these other pages. Profiling, I know we've talked about things like the JSON page before or the XML page where it talks about the serialization formats. So these are just kind of the documentation around how to do different things that are in the standard. So in this case, this is going to go through a lot of the information that I was just talking about. So you can see first a glossary, and these are important things to keep in mind when we talk about profiling. This first one is an implementation guide. So an implementation guide is usually what people are thinking of when they think of profiling. It's kind of a group of profiles and all the documentation, all the artifacts, everything kind of put together into one group of things. So one of the examples here is US Core IG. That's a good example one with qualifications here. We'll say it's good because it's very extensive, it's very well documented, it has a lot of components to it, so we can look at a lot of different things. However, it is challenging because it's a very complex implementation guide. There's a lot there. But it is a good example, and I'm actually going to be using it and one other one, the IPS, or International Patient Summary, just so that we can highlight some of the differences and kind of compare and contrast some things. A package, you can see here a group of related adaptations that are published as a group within an IG. So what this is saying is that when you go to download US Core, you can get all of the different profiles all together in one package. And typically those are NPM packages and they're published on the registry and things like that. Conformance resource, because I don't know if we've come across that term before, so I want to jump into that too. When we talk about resources, generally we're talking about things like a patient, or an observation, or even an organization. They are representing kind of real world things. In this case, a conformance resource is saying I'm talking about how to use the specification. So profiles are conformance resources in that you create an instance of them to describe how you're modifying the standard, and it doesn't have any relation to a real world actual patient. or observation or anything else. And then the profile, which is what we're going to get into here, is actually one specific structure definition, and the kind is a constraint. And that's just odd in part because it can add extensions, but that's just historically how they were initially added. Excuse me. So when we talk about profiling, often what we're really talking about is using or creating an implementation guide or an IG, but again, we can look at it in a little more simplified version here. So this page is going to go through a lot of detail on some of these things. So talking about what conformance resources are, how you actually advertise that you're supporting them, things like that. The big trick here is what I was talking about before, this piece here, extending and restricting the API. So you can do a lot within a profile. You can change how resources are kind of what is present in a resource. You can add new search parameters. You can add operations. You can do all kinds of things within an IG, which is kind of, again, all this part of profiling. For this first part, we're going to really focus in on what you actually do to resources. So in this case, we're going to talk about extensions and we're going to talk about constraints. But just to be aware, when you talk about, that's why they mention the whole API, is that you can create new search parameters, you can create new operations, you can do all of these things within this context. Like anything else, there are rules about what you can do. So one of the common things here is cardinality. So these tables, we can see there's base, down, and derived across. It took a little while for me to get used to reading them in this format. But all it's saying is that if you have, for instance, an element with one of these cardinalities to start with, and you want to try and move it to one of these cardinalities, what's legal and what isn't. So again, going into this, saying, for instance, we start with a resource that is optional and only allowed one element, so it's a single, not an array. If you want to, you can say, well, my profile says it's never used, so instead of 0 to 1, it's 0, 0, so it's not allowed. You can say that it is 0, 1, so it's still optional, exactly as it was before. And I'll jump over to this one and say, you can say, yes, it's 1, 1, it's actually required. You cannot change something that's a single value into an array. So that's this value and this value, saying whatever you want to do, you started with a single value, you can't change it to an array because that's going to change the serialization of a resource, and that'll break conformance. So there's no way for people to implement that correctly. And so it goes through all the different combinations there to say what you can and cannot do. Same thing with some of these other limitations. So it talks about how you can't actually add new elements. So if you want to add something new, you add an extension. You don't actually add a new element into patient. You add patient.extension with the URL and everything else. You can't break any established rules, like the cardinality rules there, or putting default values or things like that. Those are things that would break conformance with someone who doesn't know your profile. So none of those things are allowed. Here it's talking about structure definitions. And again, we don't have a tab for that, so we can just go to structure definition. And this is the resource that's used to actually define structures. So resource, complex data types, all these things. These are all built around structure definitions. And this is actually how you define profiles as well. So the reality, and we'll jump into that at some point, I'm sure, is you're not going to be defining these by filling out, creating a JSON or an XML with this data in it. You'll want to use a tool. There's several different tools that are available that help in profiling. You would not want to go through and create all of these things yourself. So generally, you'll use, there's a tool, open source, free, the IG Publisher, that goes through and does all these things. And lately, I'm partial to something called FHIR, FSH. And you can see here fishschool.org, and I'll put that link here if you want to start looking around and playing with more profiling. This is a fantastic way to define profiles. Much easier than trying to do things with this. So we can jump back here. One of the things they talk about is differential versus snapshot. And this isn't something you've seen in the base definitions, but we can see if we jump into, and we'll jump into US core patient here. We'll jump back and forth a little bit. You can see there's this differential view and a full view. So the differential view is just showing what they've changed in the specification. So in this case, you can see these flags that are must support. It's kind of difficult to see. Here you can see that this is grayed out, and this is grayed out, for instance, because it's unchanged, and these are not grayed out because that is not changed, and this is not grayed out because it is changed. And so it's a little more obvious in the full view, which we'll get to in a second. But you can see these are all the things that have been changed in US core patients. When we go to the full view, that's kind of merging, so it has the full patient definition and everything from US core patient, so you can get a full view of it. And so here you can see you lose that piece that you get in the differential about the grayed out or not, but you can see then everything all together. Slicing, this is a pretty complicated thing to do, and that's again why if you're trying to define any of this, I highly recommend using some tool to do so. But this is the way that you define things within arrays, essentially. So if you say, I'm going to have extensions, and extension is just an array of extensions, and you say, I want to have this particular extension. So jumping back to US core, I want to have US core birth sex, which has this URL. The way you actually say that this is here is by defining a slice on extension that says you can have, in this case, 0 to 1 extensions that have this particular URL and have this value type. In this case, it's a code. Again, I don't recommend trying to do this by hand. A lot of the tooling kind of smooths this over if you're trying to define one. And when you're trying to use them, we'll get into the code about how to do that in one of the future videos here shortly. Discriminator, again, this is part of slicing. So this tells you how you're slicing, essentially. And so in this case, we were saying before we're using the value of the URL for extensions because the URL is required, and it's pretty easy to just say, does it match this value? There are all kinds of advanced things you can do here, saying, exists or different patterns or different types, things like that. They're not things you need to worry about to start with, and then we'll get into more detail as they come up. But you can see there's good descriptions about what these kinds of things are, and some of them even specifically say, this is not commonly used. So we can jump down a little bit more. Slice cardinality, we talked about that before. Just cardinality in general. Is something required, optional? Is it one? Is it an array? You can do that within slices. So you can say, this extension must be present at least once. This extension must be present exactly once. Can be, all those different things that you can play with cardinality, you can define as well. Reprofiling and reslicing, I'm not going to touch on too much here. This is just saying essentially when you build on top of other things, you can keep building and extending. So if US core patient defines 2, 3, 4 extensions, you can go and build your profile on top of that that adds another 2, 3, 4 extensions. The trick is as long as no one puts this closed type on there. So if you tell a slicing rule that it is closed, it means that's it. No one else can build on top of it anymore. It's to be used pretty sparingly, and I believe there's documentation saying that specifically. Only use it if you are really sure that you need it. So if your use case says, by adding this extension, I need to make sure that you're only using it in this context and no other context. So things like perhaps a modifier extension that you're saying, I'm really changing the default meaning of this. Other than that, you wouldn't want to use it. And even in those cases, you probably want to think twice. So that is there. And then we get to extension definitions. There we go. And so you can see there's a link here to this other extensibility page. So there's another one of those pages that's just talking about how to use extensions and how to build them out. Again, I highly recommend using tooling if you're going to do this, instead of trying to actually type in this JSON and have it published somewhere. And there's plenty of tooling available. So of note, again, as I mentioned, our modifier extensions, and we've talked about those before. But here you're saying, for instance, on patient contact, you might have a modifier saying this is specifically not to be contacted. So, if you're putting your next of kin, just because you need to have a next of kin and it's not someone you talk to, you're never going to get a hold of me there. But if I needed that on record, I would need to put that contact information in a patient contact, for instance. But you're never going to get a hold of me there. Things like that. So again, recommend reading. It is kind of dense, so that's why we're doing this video. Binding definitions, same thing, and this is similar to cardinality. We talked before, I believe, about how you use binding strength, and there is a link to more information there as well when you talk about how the binding should be understood. And so let's see. Where's the better definition set of that? There you go, binding strengths. So here you can see you can have, for instance, required bindings. So you say this has to be one of the values I've specified. You have extensible. So you say that it shall be one of these values unless it can't be, and then you can use something else. Preferred is one step down from that, saying please try to use these, but at the end of the day, use whatever you use. An example are just, hey, here's the type of thing you can use, define something of your own and figure it out from there. So the reason why this is in profiling is because, same thing, you can change these as you do profiles. And again, there's another one of these tables, derived across, base down, saying, if you start with required, your only option is to leave it required, all the way down to if you start with example, you can make it whatever you want. So it's pretty flexible there. But again, the goal here is making sure that even if someone doesn't fully know about your profile, they can still use the resource as intended without causing patient safety issues and things like that. Must support, this is a pretty contentious part of the specification right now. And really, part of the problem is that what this is doing is saying, a system must be able to store and retrieve it. You must display it in the UI, put it in an output report, or etc. And the point is that what support means is going to be different in every context. So if you're talking about a server that's just storing things, must support is pretty simple. You have to make sure that you store it and retrieve it. That's pretty straightforward. If you say I have the user interface where this element is being used, well, I do need to display it. I might need to have it just in the UI. It might take me to a completely different screen. It might present an alternate UI. Going back to our example before, for instance, of that modifier extension, just saying, having a little flag saying this is a modifier extension, do not use, that's probably not in the spirit of must support. You would probably want in the UI something much clearer to say this is not to be used for contact and things like that. So it's pretty loose in what this means, and different implementation guides are supposed to declare exactly what they mean when they say must support. So that's something you'll want to read about in implementation guides when you do. But just in general, if you see a field that's must support, know that you're assumed to be doing something with it. Search criteria, again, similar. We were talking about this is for the API instead of the resources themselves. But if you, for instance, go and add your My Patient extension that you've created to keep track of whatever data you want, you might want to be able to search on My Patient extension. And in that case, you'll need to add a new search parameter for patient that the server can support and the client can then query it. So it does talk about how to do all of that and talk about how to try and support multiple profiles, which is very tricky. Not in and of itself, but just because often any time you would want multiple profiles on the same resource, there's going to be some sort of conflict. And so, yes, there are rules about how to do it, but in practice, it's going to be pretty complicated. So, and again, we'll jump into an example here. So for this example, I'm actually going to pull up two implementation guides. The first one is the one we were talking about earlier, US Core. And again, this is even linked as an example there. This is a set of profiles to help interoperability in the US. So again, when we talk about the portability of FHIR, we're saying it can be used in anything, but we also want to say for better interoperability, what are some assumptions we can make about these resources in question? So there's a lot of text, and like I said, it's a good and bad example because it's very well defined, very filled out, but it's also very large. So in this case, we're going to focus in on just a smaller piece, which is the US Core patient profile. And that's what I was linking to here before. So we can see the first thing is it's talking about, this is the text. This is the important, easy thing to read and understand, talking about what a patient has to have, what it has to support, things like that. And again, must support is defined in this implementation guide. So there's a page here that talks about what must support means. But in this case, we want to look at kind of some examples of constraints and some examples of extensions. So we'll start with a constraint, and we can look at this name section. So that's what we're going to kind of drill down into. So if we look at patient, which we don't have up, so we'll open up a tab with patient here so that we can see. We can see name is human name, and we can drill down into that, but we don't need to worry about it yet. We can start by seeing name is 0 to star. So the cardinality is 0 to star. So it's an optional array. You can have 0 or more elements. When we look at the US Core patient, we can see this is not grayed out. And we can see one of the things they've done is made it 1 to star. So we're saying, yes, it's an array, but you have to have at least one name available. That makes sense. Now we can see that we've drilled down in the profile, we've actually drilled down beyond name into family and given. And in patient, we only had name, human name. And the reason is if we look in human name, we can see there's a bunch of fields here too. Use, text, family, given, prefix, suffix, period. And these are all optional. So the cardinality in all of these is optional. So it says even if you have a name present, it doesn't have to have anything in it. US Core says, well, you do need to have something. And that's what this text here is. It's saying either you'll have a given or a family, or you'll have a data absent reason, or a DAR. That's often referred to as a DAR. So here you can see they've specifically called out family and given as must support, so that they show up here in the list. But then there's also this data absent reason extension that's allowed. So it's saying you have to have a name, and that name will have one of these three things: a given, a family, or a data absent reason. For comparison, I'll pull this up here. So I'll go through the same thing. This is the International Patient Summary Implementation Guide. And so this is kind of the a counterpart, if you will. Just like there's US core, this is kind of the kind of core assumptions that people can make. Same thing, constraints and extensions to try and make things more interoperable instead of just core. Same thing, it's a large implementation guide with a lot of pieces, but in this case, we're going to look at the same type of thing, patient. A note here, just because it's coming up, this UV is a realm. So we can see it in our URL, we can see it here in some of the names. If people have used it, it'll be in the different paths and things like that. And that's just essentially country codes plus UV, which is universal. So universal can apply anywhere, whereas US core is specifically written with the US in mind. The reason why that's there is not just, oh, this is in mind for that context, but there's different rules about how you do publishing, what kind of consensus you need and things like that. If you want to do international versus just US versus just Belgium versus just Mexico. So different rules for different realms. But in this case, we're going to be looking at the patient of IPS. So you can see it's pretty similar in that there's a bunch of must supports. There's some even that look very similar. Here in this case, we said human name. Same thing, it changed the cardinality from 1 to star. So it's saying, just like in US core patient, you have to have a patient name. But you can see here there is a difference. So this IPS patient one constraint, this rule, says there will be a given or a family name or both, period. So there's no data absent reason, there's no nothing. So in context, just to discuss the difference, we can see in a US core patient, you can have a name, or you can have a data absent reason that says something like, we asked the patient and they refused to provide the information. Whereas in IPS, it says, nope, you have to have a given or a family or both. So you might fill it out and say, the given and family are asked, refused, things like that, to kind of convey that, or the old example of John Doe, Jane Doe, things like that. You put in some dummy value that you know means that you don't actually know the patient's name. Whereas in US core, they went and said, well, we'll put an extension that explains when we're in those situations. So you can see these definitions are just text. There are formal definitions. If we scroll down somewhere in here, we have to go into the actual detailed descriptions for it. But they have the FHIR path expressions that you can use to validate this and all those things. And then there's just the text explaining it. So you can see they're very similar, but they're not actually compatible. In US core, you're allowed to have a data absent reason, and in IPS core, you're not. And that kind of highlights one of the challenges when you talk about supporting multiple profiles. These are both very similar profiles as far as profiling a patient for interoperability, but already we've run into an issue where we can have US core data that's not valid as IPS data. You can put in a mapping in place and things like that. So you could say, yes, if my data absent reason is present and I don't have a name, when I map it to IPS, I'm going to put in, this particular fake value, things like that. But you can see it gets complicated. So that's an example of a set of constraints. And again, these structure definitions, all of these things are here. So if we look, and this is terrible to read through the generated text, there we go. Talking about, what was it, US core 8 or something like that. There you go. This was the example we were looking at. So US core 8 is a constraint that would cause an error. Here's the human readable text we saw. And then here is an expression. And here is an XPath. So same type of thing. So it's just saying in FHIR path or I don't remember what the XPath definition language is rooted in, but it's just saying here's how you can programmatically validate that something meets those requirements. And if it doesn't, it's an error. instead of just a warning or information or something like that. So that's an example of a constraint. We can also look here in US Core at some examples of extensions. So this is saying not just I want to restrict what's there, but I also want to add some things that aren't there. Now, in this view, it looks like these are just values. And that's great for readability, but the reality is these are extensions. And so we can see that there are, if we open up one of these, we can see that this is just a standard extension that's defined, and it's an extension on patient. We can look through, again, all the definitions if we want to see, but it has this specific URL, and it's required to be from this value set. And this value set just has male, female, unknown. And you can click through and look at everything. But you can see all we're doing is saying this extension has context, because here we're saying the cardinality is 0 to 1. So we'll have 0 or 1 number of these birth sexes, which makes sense. And it's going to be a code. It's not mandatory, so if they wanted to, they could have said this is 1, 1, so that it's mandatory on everything. But in this case, they said, no, it's not a mandatory field. It's still an optional field, and you can only have, at most, 1. We can jump into something a little more complicated here. And first off, I'll make a note for anyone who's not in the US. I still don't fully understand why the US does it this way, but there's race and ethnicity, which are two different ways of saying very, in my mind, same thing. And they're actually definitionally very similar. You can see from OMB race categories, and the ethnicity is from OMB ethnicity categories. So there are different ones, but the overlap is pretty hard to distinguish different things. So in this case, we're saying this is US core race, and you can have up to 5 because these are the only valid values. So you can see there's 5 values here, and you can see they're just broken up with these vertical pipes here that are kind of hard to see probably in the video. But to that end, you're allowed to have up to 5 OMB categories present, because you could have all of them or you could have none of them. If you do have any of them, they have to have a URI matching OMB category, and you have to have a coding which is required to OMB race categories. So you can see this is a complex extension. So down here we have the URL of this extension. So if we remember in US core birth sex, we just had an extension URL and then one set of values. In this case, we have the extension URL and then 3 more extensions that are defined on it. And this is how you do complex extensions. So if you say you have multiple pieces of data that have to be kept together, this is how you do it in FHIR. And so it looks a little funny. We'll look at an example here. Again, for readability, it helps to start with this and just say, oh, you're going to have US core race, which is a complex extension. But then as you start going into it, you say, well, a US core race is actually 0 or more OMB categories, 0 or more detailed, and at least exactly 1 text. So all those things are required. So if we go, for instance, and look at examples, and if we go and grab a patient example, and we'll look at the JSON because that's easier. So you can see we're here, and again, this is just the JSON, and actually I think the raw JSON might be easier to see. Oh, no, that's going to be a hassle to open right now. So we have an array of extensions on patient, and down here we can see our US core race URL. And within that, we can see we have 3 OMB categories. So 1, 2, 3 categories. We have 2 details. and the one required text. So these are all present in one extension, which is US core race. You can already see one of the we're bumped up against one of the limitations in FHIR, and that is to say how this is structured. We have OMB category white, OMB category American Indian or Alaskan Native, OMB category Asian, and then detailed is Shoshone and detailed is Filipino. And we can figure out that Shoshone belongs to American Indian or Alaskan Native, and Filipino belongs to Asian, but there's nothing in this data that makes that apparent. And that's just the way these are defined. If you wanted to, because you can have, oh no, you're only allowed one US core race. So if they had modeled this a little differently, you could say, I'm going to have multiple US core races, and each one will just have one OMB category and one detailed and one text. But at the end of the day, again, any person looking at this can understand that, but it's just to be aware of when you're defining and modeling these extensions, how your data structure will impact what's available. So same thing here, we have another URL here, so we have another extension, and this one is the US core ethnicity. And in this case, we have one OMB category and Hispanic Latino, and then we have two detailed, Dominican and Mexican, and then again, our single required text. So in this first one, we had 3 categories with 2 detailed, and in this one, we had 1 category with 2 detailed. So you can see they're just arrays, and you can put in, if they say 0 star, you can put in as many or as few as you want. And then our simple extension, which is the best, the easiest to read, you can see in this case is US core birth sex, and the value is just female. So that kind of gives an overview of how you would use extensions. And I'll say part of the reason this is a little delayed recording this video is these can be difficult to work with in code. So I'm trying to set up some tooling to make it a little easier. Just like I talked about, there's a lot of tooling to create profiles and implementation guides. I think there does need to be a little more tooling to consume them. So I'm working on that, and hopefully I'll have it all done by the time we catch up to that part of writing code. Everything here is standard, though. You can see you can use this using any of the language packages that are available. You just need to keep track of extensions and types and URLs. You can write it all by hand if you want. You can see there's nothing in here that's particularly complicated. Well, everything's straightforward. It is pretty complicated if you were trying to write this by hand. So that's probably enough of an overview to get started with. Again, that's just touching on profiling, kind of explaining what an IG is, about either constraining or extending the parts of the standard, kind of covering what the rules are and some examples for further reading. So with that, again, if you have any questions, comments, please let me know. Again, if you like the video, please do. It helps. And otherwise, next time we will jump into using some of these code and going from there. Thank you.